Hi there and welcome to today's class. For today, we'll be discussing about integration of trigonometric functions, right? So when it comes to integration of trigonometric function, there are about two cases there. The case one is this as I'm having here. The case two will be discussed much more later in our next class, right? So let's consider case one here. So when it comes to integration of trigonometric function, there are about two cases. The case one says if I have the integral of sine x to power m cos x to power n such that m and n are odd numbers, what do you do in that case? If you are told to perform an integration such that you are having sine x to power m and cos x to power n such that m and n are odd numbers, what do you do in that case? Let me give an example of this condition here. Example, let's say evaluate the integral of sine x cube cos x to power 5 dx. I'm going to perform this integration here. So this integration becomes a condition behind what? Integration of trigonometric function. For this here, I can see odd numbers. 3 and 5 are odd numbers. So in a question, for a question of this nature, what do you do? What's your first task? How do you solve this? Your first task is to call either sine x or cos x to be u. So let one of them be u. Either you choose sine x to be u or you choose cos x to be u. Any of it is you're good to go. So for this case here, let me use sine x to be u, right? So at this point here, let u to be equal to sine x. If u is equal to sine x, if I differentiate u with respect to x, I'll have the u over the x to be equal to, if I differentiate sine x, what we know is what? I'll have cos x from what we know. At this point here, make the x subject. I'll have that the x is equal to the u all over cos x. If I make the x subject, swap position, this one comes there, this one goes there. So I'll have this at this point here. At this point here, let's proceed from here. Substituting. If I substitute, I'll have from the question it says the integral of sine cube x. Hang on, the integral of sine x to power 3, but we just say sine x to be u, so I'll have u all to power 3, right? Cos x to power 5, cos x to power 5. Next up, dx, but we just said the x to be equal to what? Du over cos x. I'll have du all over cos x. This is dot, it means times, right? I'm at this point here. What next? At this point here, what next? My next value is that, observe that cos x can cancel out cos x to power 5. If this one cancel out this, I'll be left with what? 4 of this, because I'm having cos x to power 5. It means cos x in 5 places. If this one cancel one of it, I'm left with what? 4 of it. So I'll have the integral of u to power 3, next up cos x to power 4, right? Next up du. I'll break cos x to power 4, I'll break it down. It means that we're having the integral of u to power 3 cos squared x multiplying cos squared x. Next up du. Observe that cos squared x times cos squared x will give cos x to power 4. True or false? True. All right. At this point here, but I will recall a popular trig function that says that cos squared x is equal to 1 minus sine squared x. This is a popular trig function here, right? That sine squared x plus cos squared x is equal to 1. So from there, you will derive this. Then I have this here. So this is a popular trick function here. It means that anywhere I see cos squared x, I'll put what? 1 minus sine squared x. If this is true, I'll have the integral of u to power 3, right? Or perhaps u cube. This is cos squared x. Replace it with what? 1 minus sine squared x. I have this. Next up, I'm seeing this one too. 1 minus sine squared x. Next up, du. I'm having the u here, right? The u. What's my next task here? All right, at this point here, look up please. At this point, what do you do next? Your next task is to record that, but we just said that u to be equal to sine x. At this point, we said that u to be equal to sine x, if you recall very well from the beginning here, right? So anywhere I see sine x, I'll put u. That's the meaning. Sine x, I'll put u. So I'll have that the integral of u to power 3 into 1 minus, this is sine squared x, this is sine x. Sine x will be what? U. Then I'll put my square, as in this case. This one here is this. So this one here is the same thing as what? 1 minus u squared. I have this. Next up, du. What's my next task? My next task is to expand these two. So I'll have the integral of u to power 3 into 1 minus 2u squared plus u to power 4. If I expand these two, I'll have this. Next up, du. For the sake of teaching, let me expand this one here. If I have 1 minus u squared multiplying 1 minus u squared, expand these two. First things first, pick out the first term here, 1. Multiply by everything here, that's 1 minus u squared. The second term is minus u squared. Multiply by everything here, 1 minus u squared. At this point, if I proceed, 1 multiply 1 will give 1. 1 multiply u squared will give minus u squared. Minus u squared multiply 1, minus u squared. Minus minus will give plus. U squared times u squared is u to power 4. From here, I'll have 1 minus u squared will give minus 2u squared plus u to power 4. This is the answer I had here. When I expanded this, I have this. So you can see they are the same thing here, right? So what next here? So from here now, I'll have the integral of u to power 3, or perhaps better still, I'm going to use u to power 3 to expand everything here to save time. So u to power 3 times 1 is u to power 3. U to power 3 minus u to power 3 times minus u to 2u squared. I'll have minus 2 u to power 5. 3 plus 2 will give 5 here. Then I have minus 2, as in this case here. This is plus, I'll have a plus sign here. U to power 3 multiplies to power 4, I'll have u to power 7. Add their power from the causes of indices. Add their power, I have power 7. Next up, I have du. At this point here, what next? So I'll use the integral symbol to multiply through these brackets. So integral times u to power 3, I'll have integral u to power 3. Attach the u to it, I'll have the u. I'm done with this first one here. This is a minus sign. Integral times u to power 5, I'll have integral 2u to power 5. Attach the u to it, that's the concept. Next up, plus, if you're familiar with the general method of integration, you should know this, right? So multiply the integral with this, the integral of u to power 7. Next up, I have the u here. What's my next task? Next task is take out constant term outside the integral sign. It means that we're having the integral of u to power 3 du minus, this is 2 is a constant term, outside the integral sign, as in this case here, big out to outside here. Left with what? U to power 5 du plus the integral of u to power 7 du. At this point here, what next task? I will integrate u to power 3. If I integrate u to power 3, I'll have u to power 3 plus 1 all over 3 plus 1 will be down here I'm done with this one. Minus 2 into integrate u to power 5. I'll have u to power 5 plus 1 all over 5 plus 1. That is just add 1 to the power. And whatever you're having at the power, put it down as the denominator. That's all. This is plus. If I integrate to power 7, I'll have u to power 7 plus 1 all over 7 plus 1. Next up, plus c. We call plus c constant of integration. At this point here, if I proceed, I'll have u to power 4 all over 4 minus 2 u to power 6 all over 6 plus u to power 8 all over 8. Next up, plus c. All right. Of course, 2 here 1, 2 here 3. So it means I will have u to power 4 all over 4 minus u to power 6 all over 3 plus u to power 8 all over 8 plus c. At this point, but we know generally that u is equal to sine x. So if u is equal to sine x from the beginning as we established, it means that I will have that u was what? Sine x. So have sine x to power what? 4 all over 4. This is minus. This is u. I have sine x to power what there? 6 all over 3. Right? As in this case, next up, plus. This is u, which is sine x to power what there? 8 all over 8. Next up, plus c. This becomes my answer after integrating this function here. That sine cube x cos 5 sine cube x cos x power 5 dx will give me sine x to power 4 over 4 minus sine x to power 6 all over 3 plus sine x to power 8 all over 8 plus c. So the condition here is that whenever your power of sine x to power m and cos x to power n are odd numbers, the condition is that you pick either sine x to be u or cos x to be u. In this case here, I use sine x to be u. Then I proceed with my solving. I have this. The case is that if I use cos x to be u, will I have the same answer? No. But whichever you're using, ensure that your procedure is correct. What you need to avoid is that if I make u to be sine x, does not mean that I'll have the same answer as if I make u to be cos x. So u to be sine x give me this. If I make u to be cos x, does not mean that I'll have the same answer. The answer will not be the same. But ensure that your procedure and steps are correct. So the task is that whichever one you want to use, when it comes to odd numbers, you can use either sine x to be u or perhaps cos x to be u. These are the concepts behind integration of trigonometric function. If you are interested in assisting our quality video content creating, you can simply assist us with our bank detail, as you can see in front of you. And also, you can also join our WhatsApp group to further communicate together and help you to pursue your academic performance. All right, I'll drop the link to the WhatsApp group in the description of this video. So check the description of this video. I'll drop a link there. See you in our next class.